Okay, please confirm if you can see the slides on the screen. Right, okay, good. So today we'll continue with Cleanroom. We have discussed a few basic things about Cleanroom. So we've gone through how does it look like when you have to be in a bunny suit, okay? And then we have discussed about what is a cleanroom, what does it take to be a cleanroom, okay? The level of particles for different classes, and then what it takes for you to get into the cleanroom as far as the procedures are concerned. And then in terms of the air filtration, the HEPA and ALPA filters that you can find on the ceiling of the cleanroom, and the exchange of air and circulation of air in laminar fashion in order to maintain the level of the cleanliness in the clean room. Okay, so the turbulent versus laminar condition, the classes for clean room. If you look at the FED standard 209E, so we've discussed a little bit on class 1 up to typical room air condition, and sources of contaminations, okay, particle characteristics, and I think we stop here. so by now you should be clear already, at least with the basics of clean room knowledge, right? Clean room knowledge. So we stop here where we discuss about the contamination sources, and we know that now people or human are the source of contamination, main sources of contamination. So we contribute about 75% of the contamination sources in the clean room. So where else, where we find another contributions from ventilation, for example, from the filters, they're not working properly, the design of the space, the room structure, the equipment, right, the movement. So you can already see now that you'll find a couple of moving equipments or moving tools in the clean room. For example, the basic one that you have probably watched in the videos on eLearn, the car system, okay, transportation system yang bawa wafers on our heads. So those are moving, one obvious moving system in the space. And we also have other moving parts like in the equipment itself, even though most of the parts are moving within another environment, right? So they are enclosed in a space in the equipment itself. So even though that is the case, we still have sources of contamination because wafers are moving inside the equipments, and you have robotics arms and valve and everything, and the gases and the tubes and everything coming into the chambers or coming into the spaces for and interacting with the wafers that's being processed. Okay, so let's look at this one by one. So if you look at particles, for example, okay, particles, particles can be killer defects, right? So depending on the size, the shape, and everything. So if we talk about killer defects, so that means the particles can cause measurable impact to circuit function or completely destroy the chips, right? So they may be visible and they may be invisible as well. So well, visible here means the big one by naked eyes. So invisible ones are the ones that need to be probed or investigated under optical microscope or in fact SEM, right? So some defects are killer. So if you look at the typical operation of every process, we're we're gonna look at the processes later on. So you will see later on, every process will have their own wafer, process specifications, right? Process specification, process specs, process spec or process specifications. So in this case, for example, if you talk about one process, say a diffusion process, and if you look at the specs, so there'll be specifications in that particular process that are related to a particle control. Okay, particle control. Particle control. So you cannot run any process or you cannot run any equipment without any specification. So semua benda akan ada spec. Bila you join company, those are doing production. So specifications are the compulsory documents that you should have. So basically, kalau tak ada specification, there won't be operation at all. Okay, if you talk about process specs related to the process, then we talk about process specs, right? Process specification. If you talk about specs related to equipment, then we talk about equipment specs. If you talk about measurement specification, then we're talking about measurement specs. So every single thing in the fab or in the factory, like you know, front end ke back end, you will see specifications attached to it. Okay, so sampai you nak run, nak press button pun, there'll be a specification for that. What to press first, how do you press, whether it's color coded or how many steps you have to go through in order to run wafers, for example. Nak load recipe, nak load parameter pun semua ada specification. You cannot simply load recipes to run certain process or to do certain maintenance on the equipment. No, semua benda ada specification. Okay, so there'll be hundreds of different specification for related to one department only. Kalau you talk about lithography, for example, you'll probably be seeing hundreds of different specifications on process, on the measurement, on the equipment related to the specs. And one of the specs is particle control. So dalam particle control, you will see what sort of particles are tolerable, what sort of particles are not tolerable, and how many counts can we afford to have them on the wafer. And how many counts, if you found the particles on the wafer, then you need to go and shut down the process equipment. Okay, so and these particles are divided into a couple of categories. For example, killer defects. Okay, killer defect ni kalau you ada satu dalam atas wafer pun, you will need to shut down already. Okay, for example, katalah you scan, you have a wafer, then you run process A. Let's call that process as lithography process. Patterning, we're going to learn later on, don't worry yet. So after the process, say you find one particle of certain size. Katalah dia besar juga, say a couple microns, be micrometer in size, and then only one count. Only one count. So, and this defect is categorized as killer defects, where you cannot have any at all. So that means dalam process tu, you'll see that if you have one of this defect, so for example, I call this circular defect because this is one of the real defect. Dalam lithography, siapa yang join lithography, you'll find this defect. This is one of the killer defects that we have in litho process. So you ada satu je, then it's enough to cause your equipment or process to shut down. You jumpa satu je waktu you punya scan, defect scan, then it's enough to shut down either equipment or process or both. So just imagine you ada satu tumpuk je, then equipment shut down right away. So that means no more running mass production now until you solve the issue, you find the root cause, you've done your corrective actions, you are sure of your preventive actions, and then if it's related to the process, a recipe ke parameter ke process step or something has changed, or you have no ideas of what's going on, the process has to be shut down as well until you manage to find the root cause, you've done corrective actions, you figure out the preventive actions, so on and so forth. Then only the equipment or the process can be released to run production again. Okay, so this is all spelled out in the spec as well. Okay, you nak release production punya equipment or process back to production, to run production. There's also a spec for that. The spec ni you akan go through certain flowchart. Okay, if yes, then this way. If no, then that way. If more than certain count, less than this way. If less than certain count, this way. Then what to do next, this way. You will be dealing with a lot of flowcharts if you talk about specs, right? So in this case, if you talk about circular defect, then it's categorized as killer defects. So therefore, it results in immediate shutdown of the equipment or the process because it will just destroy the device. Okay, some other defects are called cosmetic defects. They are visible but may not pose any severe impact to the circuit function, to the chip, may not be so dangerous to the chips, right? So in this case, you need to have you need to scan for how many defects do you have on the wafers, and whether or not you have them on other wafers as well. So, and see whether they are above the count or below the count that's spelled in the specs. Okay, so certain cosmetic defect you can probably tolerate, say hundreds of defects or 50 or 10. Really depends on what sort of defects. So in the processing later on, you'll see that every single defect has a database. So macam kalau you ada circular defect, then you ada what's the possible sources, what do you have to do, how do you prevent. Dia dah ada database because we have been running fabs for years, so we know pretty much the history and the symptoms and how can you solve and everything, pretty much. But even then, there are some conditions or some circumstances where you just can't solve the defects, right? So every single defect is categorized unless you tak pernah jumpa langsung defect tu. So maybe it's due to new chemical or new gases or something, but most of the defects are already identified, right? So you can just open a database and check what sort of defect is this and how does it look like, how big is it, how many can we tolerate, and all this stuff, right? So specs. So you'll be driven by specs. Okay, hundreds of different specs. Nanti kadang-kadang you just macam berpinau mata tengok spec. Too many specs. So specs are procedures that you have to follow exactly, right? If you found any problem with the spec, you have to change the spec. You have to update the spec, and then get it approved. The moment it's approved, everyone has to follow the specs, right? So there's a set of procedures that you have to follow strictly without any compromise. So kill rate, percentage of times a particular defect can kill a die. Or die to chip, satu chip tu. So if you have that kind of wafer, then say katakanlah you ada this kind of die, then this considered as a die. Satu. So you may have like thousands of dies on the wafers, right? So it really depends. So metallic ions are another type of contamination, can alter characteristic of the devices, because if you have metallic ions, then it can induce a conduction path. So dia ion. So metallic ionic contaminant, mobile ionic contaminant, MICs, initially located in the benign area of the silicon. Well, this depends whether it sits at the benign area or the active area. Benign means passive, passive or active area. So it may also migrate towards the device and cause failure because it's mobile in nature. Okay, so it can migrate across from passive to active areas. So sodium is the worst MIC. Sodium. Where do you find sodium? Do we have sodium in our body? Or can we produce sodium from our body? If you're running, a factory, for example, with handling wafers, can you contribute sodium in any way? Anyone? Sodium dari mana? Peluh kan? Sodium peluh kan? So sodium is the worst MIC. So that's why you have to be properly gowned and gloves and everything. So to protect, again, to protect the wafers against us, right? Not to protect you against the wafers to protect the device. Nak jaga device tu, kita kena buat whatever it takes, right? So it's very active and mobile. Sodium, so sodium is present in skin, hair, sweat, right? Kalau peluh menitik then done, habis. Also present in chemicals, semiconductor industry requires low sodium grade chemicals. So when you use chemicals, when you buy chemicals, you need to have the SDS. So data sheet, previously it was called MSDS, Material Safety Data Sheet, now SDS, Safety Data Sheet. So dalam tu you ada content, do's and don'ts, you can mix this, you can operate at certain temperatures, everything spelled out in SDS, right? So dalam tu ada details of everything. Right, another contamination is chemical contaminants. Trace chemicals in water and process chemicals can modify process effects. Okay, even though the water and the gases are controlled. Okay, so water yang masuk dalam, dia ada satu department dekat factory ni. It's called facilities. Facilities ni they'll be in charge of the incoming water, electricity, gases, apa benda lah, all the precursor material yang sebelum sampai ke equipment tu, all the pipings, all the sensing, all the flow rate, all the safety level or whatever, alarm level, semua facilities akan in charge. So the only facilities engineer in charge of electrical, chemical, gas. So they are typically engineering background, electrical, high voltage, mechanical, in charge of aircon system, air handling unit, a fire protection system, sprinkler kat atas ceiling, pressure and everything. So all by facilities, right? Incoming gases quality, incoming water quality, ultra pure water, DI water, whatever. So right, everything that comes into the factory will be maintained, will be governed, will be managed by facilities department, right? So usually dalam facility ni you're gonna see like gas engineering team, chemical engineering team, water engineering. So every group tu dia ada dia punya own engineering team. Then to maintain all this, to make sure that whatever is coming into the fab, into the equipment, is super clean, right? Because if you have traces of chemicals in water, in chemicals and gases that are beyond the tolerable limit, then they will kill the device. Okay. Photoresist is the most sensitive one. Trace of chemical. We're gonna learn this in lithography process. You're gonna use photoresist. So it's a polymer sensitive compound, a light sensitive polymer compound. Okay, so it's a polymer photoresist, but then it's light sensitive. So dia akan respond to illumination wavelength, certain illumination wavelength, where it's designed to respond in order to induce certain reactions on the wafer in order to form the layers that you want, right? The structure, the features that you want. So polymer, light sensitive polymer compound. So it will respond to certain wavelength only, depending on lithography equipment that we're going to discuss later on. Okay, there are outline 365, DUV 248, aluminum fluoride 193. And then sampai lah ke EUV, extreme UV 13.5 nanometer illumination wavelength. So every group of lithography equipment, which is the respective illumination wavelength, has its own category of the photoresist. Okay, so they can respond to a specific wavelength only. Kalau you pakai wrong resist on the wrong system, you won't. Nothing won't happen. Nothing will happen, right? Nothing will happen. Right, another sources of contamination, bacteria. Bacteria can form in the water. Okay, so that's why you have to control the incoming water quality. Solution is to keep the water flowing. Yes, of course. Bacteria can cause devices to fail. Okay. So another sources of contamination is static charge. So attract particle to the surface due to static, right? Static particle are very difficult to remove. So static is a big issue, especially if you're talking about low technology node devices, yang high end punya, static will be very, very crucial. Creates ESD. ESD ni main issue dalam fab. Electrostatic discharge. Right, so it will destroy the gate aux. So if you talk about MOSFET, for example, then so your gate aux will be damaged, right? Gate aux. the red region here. So destroys chrome particle on photomask. So we're going to discuss later on about this reticle. Bila kita nak expose, bila kita nak print kita punya circuit on the wafer, then you need to have the pattern, right? Pattern or mask, or we call it reticle as well. So the chrome pattern can be destroyed by the static charge. That's why monitorings have to be done. So it can be controlled by using anti-static materials, discharging around ground straps, even though your equipment kena ground, kena grounded, kena connect to the ground. Okay, so to eliminate the static implication. Install ionizers to neutralize the ions in filtered air. So akan ada ionizer in spaces in the fab. So another sources, people, okay, human. So we emit 10 to the 5, 10 to the 16, up to 10 to the 5, 10 to the 6 particle per minute when in motion, walking. Kalau kita buat apa-apa, 10 to the 5, we discussed last week. So the particles can be from the clothes, skin flakes, hair. So kita dah tutup, then okay lah, breath, okay, kita beri nafas, makeup is fine, no. Sweat, saliva, okay, saliva of course, you don't spit in the fat, right? So, but yeah, contamination sources. For these reasons, we wear bunny suits in a clean room, made of polyester, Gore-Tex, helmets, a mask, double glove in some condition, booties, right? Boots. So yeah, that's why we have to be fully gone up. Water. So has minerals, particles, bacteria, organic. We have all sorts of things in the water. So that's why they have to be controlled in terms of quality, right? So filtration process is normally done. So, well, many techniques are deployed to kill the bacteria, DI water. The water purity is measured using resistivity monitor, okay? So greater resistivity means more pure, okay? For example, if you talk about DI water that we use in the fab is typically 18 mega ohm cm, 18 mega ohm cm of resistivity. So that's the resistivity of that water. So we measure that, okay? So that water, on the other hand, if you look at this, is 1, 2, 3, 4. 2 times 10 to the minus 4, okay? 2 times 10 to the minus 4 mega ohm. So if you compare to 18 mega ohm, so that's like 5 orders of magnitude difference in terms of purity, okay? So that water ada macam-macam. Other sources, chemicals, include metallics, particles, particulates, and other chemicals. Chemicals are usually graded, commercial, reagent, electronic, semiconductor. So kita ada banyak categories of chemical for range of different applications. So metallic contaminant, for example, in the chemical is usually spelled out in the SDS. Okay, so it has to be in ppb, part per billion range, in order to be considered as safe for operation. Kalau lagi tinggi daripada itu means it's not safe, right? Particles must also be filtered down to less than 0.2 micron, depending on process that we're talking about. So it's not a single spec, yeah, it's not a single number. So it depends on certain size, certain counts, and all the stuff, right? So every chemical that you use in the fab has to be controlled in terms of this quality, right? Gases are also controlled. So we use all the possible gases that you can imagine in the fab, right? From the inert one to the most dangerous ones, okay? Oxygen, nitrogen, argon, hydrogen, specialty gases. Specialty itu means the specific one untuk certain process. Silane, SiH4, yang senang terbakar, flammable gases. Well, they have range of different gases. So contaminants in the gases include other contaminants, other gases, water vapor, metal, ions, particulates. Okay, so water vapor particles are controlled as well. So again, this is not a single number kind of thing, just an example. Okay, so plumbing must be leak free. Kalau tak leak free nanti if you have gases yang toxic gases, for example, like phosphine, okay, Heparin, P2H6. Ini untuk doping. So this is for N-type, for phosphorus, this for P-type, boron. So phosphine and dibrate. Okay. Tak masuk lagi arsine and everything. Arsine, arsenic. Very toxic. So dangerous. Kalau leak, then dia akan ada leak detector lah. Okay, leak sensor yang akan activate that gas leaking. Then if you're doing the job in the fab, for example, and then suddenly there's gas leaking, what do you think will happen? Any ideas? You tengah run you punya process, and then atau you tengah buat troubleshooting of your robots, and suddenly alarm gas leaking. So what do you think will happen next? Any guess? What will happen next? Orang cuba ke? Apa jadi? Leak sensor activated. Belongs to, say, phosphine. What do you think will happen? Bakaran? Apa you kena buat? What do you think will happen? Next, immediately, what do you think will happen? To yourself and others. Lari, lari lah kan. Well, lari is the essence of what you're doing lah, lari. But then we call that evacuation, fab evacuation. Ni part of the safety training lah nanti you can go to if you're working in a fab. Okay, but essentially lari lah, lari semua lari clear. So bila you evacuate the fab, say you're working on your process 12 PM, tengah panas, then you can evacuate the fab, right? You can evacuate, macam fire drill, for example. Then how do you think you will evacuate the fab with your gown and everything? Macam mana tu? What do you think will happen? Just nak teka je. You teka je. What's going to happen if you do fab evacuation while working in the fab 12 PM, say before lunchtime? Evacuate, you have to evacuate with your gown, with your bunny suit. So that means you kena pergi ke assembly area, say usually dekat parking area, with your suit, right? With your bunny suit. Macam frontliner ambil patient COVID tu. Panas. So you'll be going to the parking area 12 PM, fully gown. Tak boleh buka lagi tau. Tak boleh buka lagi. You're not allowed to remove your bunny suit yet. So dekat sana dia akan ada apa ni? Couldn't remember the safety team, emergency response team, ERT team. So ERT team ni dia akan datang and coordinate all the apa ni? Kira berapa orang semua kan? Kira berapa orang and see how many have scan masuk fab and everything. So you're not allowed to remove your bunny suits just yet. Kalau panas lah. Kalau sejam lah. Kalau tak cukup orang kan, you have to wait then. You cannot go away from the assembly area unless everyone from the fab is there. Okay, kalau ada, you don't know, someone mungkin suffocated ke dengan gas, tak sempat lari ataupun tak perasan tengah buat maintenance in the equipment, but tak dengar ke, I don't know, for some reason. Right, it happens. Tapi most of the time we are clear lah. So just in case, get the numbers right first and see your buddy, see your colleagues, whether they are around. You'll be categorized as your in your department. Okay, photo, satu line, etching, QA, all the stuff, right? So only if everything is okay, fine, then only you'll be allowed to masuk balik dalam building, masuk dalam, depending on the situation in fab, and apa ni, ungown lah, remove your bunny suit. Until then, you'll just be there at the assembly area, waiting for the procedures to complete. So banyak kali ya jadi kalau tengah panas, you have to go out to the parking space 12 PM in your bunny suit. I couldn't imagine. Kalau pagi okay lagi, kalau petang okay, kalau 12 PM then wow. Okay. So equipment, other sources of contamination. Equipment can generate particles because you have robots pretty much everywhere, automations everywhere. So you had a robot movement, x-axis, y-axis, z-axis, a couple robots in one equipment, and you have like hundreds of different equipments in the fab. So they do generate particles. So due to moving parts, bearing, wear and tear in equipment, so deposits inside the chamber. So that's why we have to have PM to the equipment. So we have to have PM, preventive maintenance. Okay, preventive. So allow some of you join equipment engineering team. So this is one of your JDs, right? Job description, preventive maintenance. So you have to do like weekly PM, monthly PM, quarterly PM, semi-annual PM, annual PM, biannual PM. Everything is spelled in the spec. Spelled out in the spec. So weekly, what you have to do, monthly, what you have to do, everything. So the longer the period is between the specs, say weekly, maybe you need like 1 hour to get everything done. Monthly, you probably need 4 hours, for example, depending on the equipment. So if you go for longer PM, yang lebih rare, yang less frequent, then it's going to be longer and longer. Quarterly PM, say 18 hours, semi-annual perhaps 2 days, annual PM perhaps 4 days. Okay, so what to do, you'll be there on the equipment straight, and you tukar ikut shift, of course, right? But then these are the things. For example, as you run the equipment, as you run the process, you will generate deposits in the equipment. Okay, layer ke deposition or chemicals that can stay on the cup ke apa kan, the chamber, everything is chuck, everything. So they will affect the performance of the equipment and in fact the process well. So that's why you need to have, say, weekly PM to do certain cleaning on the deposits to make sure that they don't accumulate further and further. Kalau you tak buat, you skip the PM, then you will only see your next PM in the next week. So that means you just keep 2 minggu. 2 minggu, then just imagine the amount of deposits generated in the equipment, on the robot arm or something. So that will induce contaminations to the wafers. Okay, so there's no single procedure for this because it really depends on what sort of equipment, what sort of process the equipment is doing, and how dirty is the process within the chamber, okay, within the space. Lagi senang kotor, the more frequent it takes for you to do the PM, right? If it doesn't generate that much of particles, then maybe you'll probably have a more spacious duration between PM. Okay, so preventive maintenance. So the fab, kalau kita schedule your maintenance, you plan to do your maintenance, then we call that SPM, preventive maintenance. On the other hand, let me just introduce you some keywords, some language. If you don't plan, tapi equipment to down, we call that UM, unscheduled maintenance. So that means tiba-tiba you run today, it's not supposed to be on PM, but then suddenly wafer breakage. Robot arm punya alignment lari, then wafer, the pickup wafer tak sampai, then dia during rotation, for example, then wafer jatuh dan pecah. Okay, so there must be something wrong with the alignment somewhere, somehow, right? So equipment engineers need to attend to this issue, and this is called UMs. Mana you tak plan lah, tiba-tiba down. 11 malam down, 12 malam down. So what's going to happen? What do you think will happen if the equipment is down night time? You are the equipment engineer, for example. Amiro, you are the EE for this equipment engineer, for example. Equipment down 12 malam. Then the equipment technician, the ET, we call that ET, equipment technician. ET will do the job first. We'll do all the troubleshooting for, say, 1 hour, 2 hours. Kalau tak boleh juga, if it's not solved, say after 2 hours, 2 hours means down pukul 12, 2 hours they've tried 2 a.m. in the morning. Kalau tak boleh solve, then what will happen? They will call Amirul. Okay, they will call Amirul. They'll call you 2 a.m. in the morning. Amirul, we have this problem and we've tried to do this for 2 hours and nothing worked. We need you to come in. So 2 hours, 2 a.m. in the morning, you kena bangun dan masuk fab. Okay? Right? So 2 a.m. in the morning. So you don't want to be surprised. You don't want to be surprised. Sometimes you will be called 3 times during your night sleep. 3 times. Saya nak bagi kat you the right mindset supaya you tak culture shock kalau you nak kerja kat fab. Yes, it's like on call. It's like being on call. Cuma you tak jaga patient lah, you jaga machine lah. Ataupun you jaga equipment, you jaga process. So they will do something for like 2 hours, 3 hours, depending on the spec. Again, it is spelled out in the spec how long do they have to do before they need to call you in the spec. Tu pun ada lah spec punya lah, very detail. So say your process is shut down, Arisha, your PT will troubleshoot first, process technician will troubleshoot. Ni untuk fact kita panggil this kind of term. Untuk other industry, I'm not sure, backend, I'm not sure. But your PT will troubleshoot for like 2 hours, 3 hours, nothing works, and they call you 3 a.m. Arisha, it's not working, your process shut down due to particles, we need you to come in. So Arisha, 3 a.m. you have to drive to the fab and get into the fab and get things done, right? And yeah, we have to use all the skills and whatever knowledge and troubleshooting method and experience, try to get it done in certain hours. Okay. If you didn't get it done in certain hours, then your manufacturing punya boss akan duduk kat belakang, you will call you. Okay, call you. There'll be manufacturing engineer in charge for every shift, day shift, night shift. If you run during my time, it was like 7 to 7 ada seorang manufacturing engineer yang in charge of the line. So kalau ada isu dia akan make sure process engineer is inside to do the work, equipment engineer is inside to solve. But dia manufacturing dia akan tengok manufacturing punya capability. So they don't want to let you take down any equipment or process. So then dia akan call you ataupun datang kat belakang you. So when will solve? How long do you need? Why is not done yet? All the stuff. Why so long? You will be asked with this question. Okay. Kalau still tak solve, you say you commit 3 hours, but then after 3 hours, 6 a.m. you still tak solve, you datang 3 a.m. tadi, then dia punya boss akan call you. This is in the specs, you punya manager atau director akan call, hey Arisha, what have you done? 3 hours not solved. Why? Then you have to explain why is it not done? How many hours extra do you need? And for what? And when can you solve the issue? Okay. So these are the things that I want you to be prepared with. It's not easy. It sounds like, okay, your fab or nice, good pay and everything to some extent. But then the challenges inside the fab to get things done is super challenging, right? So you can mentally prepare. So I used to nangis or tidak boleh nangis sebab you dah kerja tu kan? You dah ambil kerja tu. Well, I have friends yang memang menangis. But then do you think they will care? Kalau you're crying, do you think they'll care? Kesian? No. You have to get your work solved, right? Nangis ke, tak nangis ke, I don't care. I want the problem to be solved. So that's the language in the fab. That's the language in production. You pressure ke, tak pressure ke, up to you. I don't want to know. What I want to know is 6 p.m. the problem is solved. And 6 p.m. onwards, the mass production is running as usual. Okay. So no more Arisha doing troubleshooting after 6. So that's what it takes, right? So that will you have to build that up over time because you have knowledge yang you ada, tapi you have to be retrained from apa ni? You have to be retrained. You take time to build experience. During my time, let me just share a few things before we finish. I was trained for I think 6 months. 6 months bila saya join, saya first job was on equipment engineering. So I was hired as a PE, process engineer. I supposed to go to Oregon, USA to be trained in LSI Logic for 1 year, but then the plan was called off by the CEO at the very last minute. Passport semua dah prepare. I was supposed to fly to Oregon with another 9 guys for the training in the US for 1 year, suppose. Last minute CEO called out the plan. Then for some reason the whole batch couldn't go to the US for 1 year. Then we just trained on the job in Silterra and other reorganizations waktu tu, and I was reshuffled and put into equipment engineering team, and I have to be trained for like 6 months before I was included in the standby list ataupun on-call list. So maksudnya you kena follow your senior engineer lah, for example, for 6 months to know things, to tengok macam mana dia buat, macam mana troubleshoot, how long, macam mana dia deal dengan manufacturing team, macam mana the pressure is like. Then only you are included into the on-call list. Bila you dah masuk dalam on-call list, then 7 months onward, bila ada issue at 2 a.m., 3 a.m., 4 a.m., 5 a.m., doesn't matter. You will be called in because you're already on the list. macam shift lah. Kalau hari ni you standby, and then mungkin Monday, Tuesday, Wednesday, Amirul, Friday, Saturday, Sunday, Juariah perhaps, Risha, something like that. So during that time you have to be careful on your issues, right? You always want to pray there's no issue night time. You will do that every day. So I used to, just to share with you on this issue, I used to work 24 hours. So I came in 8 a.m. until 10 a.m. tomorrow. Okay. Of course, kalau keluar makan, semayang, semua tu, that standard lah. Tapi to say that 8 a.m. today, tak balik lagi rumah, 10 a.m. tomorrow baru habis solve the issue. So that's like 26 hours. So I pernah juga in my case, I work 8 a.m. today, and then malam ada issue, then I went back 11 p.m. Sorry, 10:30 p.m. I think, sampai dekat Pematang Pauh ni, dekat sini rumah Pematang Pauh. Then 11 p.m., half an hour after you came back, you got a call. Ada issue, we have done this, cannot. Then 11 plus, masuk balik fab. Sampai esok subuh baru keluar. Sampai esok subuh baru keluar. So just imagine I was scanning the defects on defect inspection. Jadi tersengguk-sengguk. So that's part of life. So, well, that's one of the many more reasons. So the pressure is one thing, but the things that you learn over time is something else as well, right? So that the skills that you learn builds you, okay? Apa yang you belajar tu akan builds you, right? So that's part of the things. And the pressure is, of course, one of the main reasons as well. So the pressure is like pressure cooker all the time. But it will build you to be someone stronger. Okay, kalau you boleh kerja fab and you boleh tahan, then you pergi kat mana-mana industry, I think you can survive or you can excel, right? So yeah, okay, contamination, you have to do cleaning up, depending on the issue that you have, and then particle monitoring, there'll be this will be done by our team as well in the department, and also by QA. QA dia akan buat monitoring ni, QA, or some people call QC, so called, they will do the monitoring of air particles and all the stuff, right, from time to time. So it's a challenging environment, in the fact. So there are a few basic rules. I think I'm almost done over time. So there are a few basic rules that you'll be introduced when you join a wafer fab. Okay, I think the same goes to some other industries as well. Back-end semiconductor, electronics, and other industry pun sama kok. Tapi just to be specific. So if you are unsure of what you're doing, don't proceed. Kalau you duduk dalam fab and then you are on the list, on the standby list, for example, dah train for 6 months, for example, tiba-tiba you jadi something, but you're not sure what to do. Do you have to press this button or no? Kalau tak sure, don't do. Walaupun you're afraid apa, some people say that you are not confident ke, tak bagus ke, whatever, don't do. Kalau you proceed, that might cause something more dangerous atau more risky. You press, tiba-tiba robot arm shutdown, wafer jatuh ke, tapi sebab you dah press, so that's too late, and then you have to present in the meeting next day 8 a.m. Why did you press? Then you nak cakap apa kalau bahasanya kenapa you press? Because I was not sure. Not sure, don't press. Kenapa you press? Don't proceed. If not sure, don't proceed. Okay? Anything, sampai ke benda-benda kecil pun, if you're not sure, don't proceed. Ask. Okay? Even though you have to ask your technician, it's okay, ask. Kalau tidak, you might screw up something. You might misprocess or screw up equipment. Never work alone. You don't know what's the risk like. Alarm bunyi tak dengar ke, or something, ada leaking, ada fire. Okay, never alone. Be with your buddies all the time. Okay, ataupun kalau you are dekat satu corner, make sure you have buddies within the radius. Okay, know the rules and follow them. Right, learn the rules. So that's why you have to go through the training first. Keep the work area clean and neat. So no things on the floor yang boleh trip you down, cable ke crossing. You will learn later on. If you do maintenance, you lay out cable kecil pun, simple cable pun, you have to barricade, letak cone, right? So you will learn that over time. Okay, barricade, say PM in progress, supaya people tak trip. Just imagine kalau you ada cable, you don't put cone on and barricade the area, say that you're doing PM, and then someone passing by carrying wafer pots. Then trip guna cable, trip kat cable tu, jatuh dengan pot tu. Okay. During my time, just to put things into perspective, one pot, I don't know now, it just depends on the technology and product. Kalau ada satu wafer ni, satu pot ada 25 wafers. So if you completed all the process for one particular technology, each wafer, 8 inch, will cost you USD $1,000. During my time, for this particular technology, but this is not applicable to all. Kalau lagi simple device tu lagi murah lah. So one wafer cost $1,000. So kalau satu pot jatuh, dia trip, boom, pecah wafer semua. Apa jadi? $25,000. $25,000. So that's like, if you convert by 4 times 4, then that's 100K, isn't it? 100K per pot. Completed chips, completed process. Selepas 3 bulan, last step, trip, boom, pecah. 3 bulan punya process cycle. So it started in January, you finish in April, suddenly the wafer breakage issue. Okay, 100K per pot due to cable ada atas lantai and not barricaded properly. So that's the root cause. Then you have to present kenapa you tak barricade properly for such a simple job. Okay, so these are the things that you will learn later on. Okay, operate equipment per spec. Operate process pun sama juga, per spec. Per spec means according to the spec, according to the procedure that you have to do, you're supposed to do. If the spec is wrong, work within the system to get it changed. If you find the spec is wrong, or can be improved or needs improvement, you have to then improve the specification, get it improved, get it approved, and get everyone yang work with the spec to be trained with the change, okay, with the update, so that they know what is the latest update. Okay, so you'll see later on as well, if you update the spec, then you have to train certain personnel who are working related to the spec. Kalau tidak, dia tak akan aware. He or she might not be aware of the recent update on the spec. Okay, no emergency exit routes, know where showers and eye wash stations are. So this happens to my colleague tengah buat maintenance. Let me finish in a few minutes. Tengah buat maintenance, dekat fab usually ada satu atas punya area tu is the fab operation. Dekat bawah is sub fab. Maksudnya bahagian bawah fab. So dekat sini ada chemical, ada gases punya supply akan naik piping ke atas. So kita akan buat maintenance kat atas. And you run all the process and PM sometimes, most of the times on the production floor. Sub fab is the supply side. So during my time, we were doing maintenance, we were doing PM, and then seorang vendor ni dia tak pakai Google, dia buat maintenance kat bawah, dekat sub fab, and someone is doing works at the fab area, and IPA punya botol tu terjatuh sebab dia tak letak kat hujung, I think. Terjatuh, and he was doing maintenance down in the sub fab, dan jatuh coincidentally jatuh dekat mata dia dan masuk splash dekat dia punya mata waktu tu tengah buat maintenance. So just imagine if he was alone down there and there's nobody system, dan eye wash ataupun shower ni jauh daripada dia tak ingat shower kat mana, so mata tak boleh buka sebab terlalu pedih. So then no one to walk him to the shower ataupun eye wash station to clean up for a few minutes. Then just imagine what's going to happen. Jadi mungkin macam tu lah, teraba-raba lah nak pergi ke mana. So body system is important, okay? And always communicate. Fab, sub fab, kadang-kadang kena ada walkie-talkie and stuff like that. You'll see later on in the fab. So know where EMO buttons are. EMO button ni emergency off, right? Emergency off. Tiba-tiba you run maintenance. This happened in GF last time when it was called Chartered Semiconductor. Seorang tengah buat maintenance kat depan, dia terlupa activate the disable button. So then bila dia terlupa disactivate, that means the robot can run if you load the process or something. Okay, then someone is doing maintenance on the robot side back there, tak aware of the robot is running, then robot tu bergerak and crash the shoulder, patah tulang. Crash shoulder, high speed robot. Theta, X, Y, Z, untuk reach wafer, dia gerak, crash your shoulder and patah lah dia punya tulang. So yeah, communication. So these are basic rule. Very basic, kadang-kadang sampai kita terlepas pandang because it's too basic. Communication is very basic, right? Wear PPE, appropriate PPE, personal protective equipment, bunny suits and whatnot. Do not take shortcuts. Kalau you say boleh buat shortcut, better not, right? You know how to get to do things faster, better not. Follow the spec. So that's why the specs are there. Because mungkin it will lead to some incidents that you won't, you've never expected, right? Follow all the preventive safety procedures, lockout, tag out, this one, all the PM safety procedures, follow accordingly. Know all the potential hazards. So read SDS. So what gases are you working with? What chemicals are you working with? What is the danger of robotic arm? All the stuff you have to be aware. Okay, you have to be aware. So yeah, and others many more. So these are only among the things that you can learn. Tapi ada banyak lagi ya. So some are really unique to the process and to the equipments, right? So saya letakkan ni yang the very generic one. So these are among the things that you have to be familiar with for the basic rules, right? So yeah, we finished clean room. Tak sempat nak cover oxidation hari ni, so we'll just do that tomorrow then. Okay, tomorrow. Okay, any questions on clean room contamination? Nope. Okay, all good. Still not so technical yet, right? So because this is just clean room and basic stuff. So you'll get more technical when we start oxidation, right? So then if there is no question, then that's it for today. Bye-bye. Thank you. Assalamualaikum. Hello. Assalamualaikum. Ya, udah lah. Enak.